Hey, and welcome back to another video. So in today's video, what we're actually going to do is we're actually going to look at how we can use async await and MVVM in our applications. So obviously Xcode 13 has come out and we can now change the way that we interact with APIs. So for this tutorial, I'm going to look at how we can use the wrappedValue API to basically interact and create a list of characters and see the improvements that async await gives us compared to using closures for, interacting with asynchronous code. Also as well, I've recently did a video before where I talked about my MVVM async await project structure. If you want to see that, I'll leave a link at it. So let's jump into this video and let's get started. All right, cool. So the first thing I actually want to look at is the model for the data that we are going to be using. So like I said, this is going to be a simple example just to show you async await and how we can use it. So in the Rick and Morty API, if you go on the rickandmortyapi.com website, if we go to docs and if you scroll down, we're just going to basically show a list of characters. So in our documentation here, there is a URL we can hit here. So we're going to use this one. So I'm just going to copy this and I'm going to actually put this in our API online testing tool, so request bin. And as you can see, I've actually already done it. So if we hit send, you'll see the response that we get back. So in our list, we're just going to show the character's name. So we actually only need the name property, but we need to actually model our data to match this response. So in our Xcode project, let's create a brand new folder called model, and inside a model, we'll write the code to actually, reflect our JSON response. Cool. So as you can see, we've got our model here. So we've got our result and it holds an array of characters. So like I said before, for each character, we're going to get the name from the response. And also we're going to use the ID. So the reason why I'm using the ID is because that's what we're going to use as our unique identifier for each character within the list that we're going to use later. So if you want to actually improve on top of this, all you'd have to do is go to the JSON, and if you just look at the result here, as you can see, I'm using the name. You can add whatever you want. So if you want to add status, you just need to add it, and then species, and then just sort out the data type that it needs. All right. So the next thing that I'm actually going to do is create a service class. So the purpose of this service class is to simply interact with the service, so make the actual API call. So in this service class, this is where we're going to be using the new async await functionality to interact with an API. And I'll also discuss the benefits of using this over a closure. So let's do that now. So in our folder, let's create a new group called service. And then I'm going to create a new file called character service and then do a bit of typing. Cool. So we defined our character service and our function to fetch our characters. Now, you may be looking at this and wondering, why have I done the character service as a struct as opposed to a class? So the reason why I did this is because with this struct, we don't need to observe any changes to it like you would with a observable object if you were, binding a view to some kind of view model. This service's only purpose is to literally execute an API request, and once it executes the API request, it will just give us a result. So in order to make this a lightweight class, we might as well just mark it as a struct. So in our function here, fetch characters, so this function is what we're going to use to interact with the service and use the async await functionality within it. So normally what you would do is something like this. Right, cool. So I finished typing it out, and obviously I spelled it out for you, but for me that was a lot to type out. So let's break this down. So what I've done is I've now introduced a error enum, so we can actually, throw errors whenever something goes wrong. Also, as well, on top of that, you'll see that I've added a completion handler. So the completion handler uses the result, so we can have a success when we get a successful, response, and things go well, and we have an error when things go wrong. And we're using URL session to call our API, and then within here, we're just doing a couple of checks and decoding our data. Depending on the status of what's going on, we'll throw an error or we'll throw a success. Now, before async await, this was valid, and most people would structure their code like this. But now that we have async await, there's a lot of problems and things that it helps us, resolve. So the first thing that it helps us resolve is this. So we've got this completion handler here, right? So what is the problem with using this completion handler? Well, what about if I actually have another function that I also need to chain after this? If I want to use these two functions in conjunction, I will get into something called callback hell. So just to show you what that looks like. Okay, cool. So in this example callback hell function, I've got two closures nested within each other. So if we had like 2, 3, 4 functions we need to chain one after the other, this can get pretty nasty and not very nice to look at. So that's the first thing that async await helps us resolve. Also as well, if we just go back to our function, you'll notice something that it's a lot of code. So just to call an API and execute a request, it's a lot of code to type. So async await also helps us reduce the amount of code that we have to write as well. And then finally, the last thing is, I don't know if you realize, but there's actually a possible issue with the code that I've written. So as you can see in the response, we're checking for certain things, and depending if something goes wrong, then we call a failure. But in this case here, we've actually forgot to call failure if something goes wrong. So this here could be a problem, because what about if we actually do get in a scenario where our response object is nil? If our response object is nil, then the user, when they're using our app, nothing's going to happen because we don't actually call the completion handler on all the paths. So async await allows us to actually throw an error, so we actually can't get into situations like this where we actually miss paths and forget to, throw something. So what we're going to do now is, well, unfortunately, I'm going to have to delete all this and retype out all over again. But luckily, async await is a lot nicer when you want to type this type of stuff out. So what we're going to do is we're actually going to remove our completion. And then after removing our completion, the next thing we're going to do is actually just delete all this code. So what I'm going to do is I'm actually going to type out the exact same code that I just written then, but this time using async await syntax, and I'll break down certain parts and explain what they mean. So let's do that now. So the first thing that we need to do in order to use async await is we actually need to mark our functions with the async keyword. So by doing so, this will actually allow us to tell the compiler that this function is an asynchronous function. So in order to do that, after your method signature, all you need to do is actually type the word async like so, and now it knows that it's an asynchronous function. So you may get an error here, and the reason why that is because async await is actually only available in iOS 15 and above. So if you're someone who's actually still supporting iOS 14, then unfortunately you're not going to be able to use this capability. But if you're a company or you're an indie dev or whatever, and you're all going to be using iOS 15, then go ahead. So in order to fix this error, there's two ways of doing it. So what you could do is, if you don't need to support iOS 14, then simply just change the iOS deployment target here to iOS 15, like so. But if you do need to support iOS 14, then what you're going to need to do is, where it shows you the error, if you just hit on that and you hit fix, it'll add a available property wrapper so that this function is actually only available in iOS 15. Now, for the purpose of this tutorial, I don't need to support iOS 14, so I'm just going to set it to iOS 15 as a default. And then what we need to do now is we need to actually handle our code in terms of how it throws errors. So with asynchronous functions, they can actually also throw. So by that, what do I mean? So if something goes wrong, you can actually throw an error and actually capture it in a do catch clause. So in order to mark this function as throws, all we need to do is, after the asynchronous keyword, is just define throws like so. So now we've told the compiler that our function is asynchronous and it can also throw an error. Now, the final thing that we need to do is actually give our function some type of return type. So because we're not using closures anymore and we're using this, all you need to do is specify the type that you want your function to return. So in our case, we want our function to return an array of characters. So let's do that now. Cool. So now we've got the base implementation for our function and it's looking all good. So you'll get an error because obviously the function is expecting you to return something. So just to remove this error for now, I'm just going to return an empty array. So now let's look at how we can use the URL session framework to use the new async await capabilities. So let's do that now. Okay, cool. So we've got our URL here and we just defining the URL that we want to hit with our API. So now we're actually using the URL session and it has a new function that has asynchronous capabilities. So this data function now, rather than using a closure, we're now going to use the asynchronous alternative. And Apple, if you watch WWDC, actually, announced that there's actually a lot of functions that they've updated in frameworks to give us this new capability, and this is one of them. So you might be wondering, why have I added this await keyword before here? Well, the reason why we need to use this await keyword is because we're saying at this point that we want to suspend this execution so that we can await the value from the service. So why do we need to suspend this? Well, if you think about it, when you're executing a network request, you don't really know what time or how long it will take for it to come back. So what we're saying here is we want to suspend and await the result back from the service before we actually carry on with any of our code. So we don't actually want to carry on with the next steps that we go to type until this comes back. So as you can see, this is a lot cleaner and nicer than us having a callback, because we're just saying that on this line, suspend the function and then resume it when you're ready to execute it and give us back that result, and then continue. So we also mark this with try. So using the try keyword allows us to capture any errors. So it's possible for URL session to throw an error, and by using try, it allows us to try to execute this, and if it does throw any kind of errors, then this function fetch characters will throw those errors as well. So after we do that, we get two things. So we get the response and we also get data. So data is the data that we're going to use to try and decode the result that we get back from the service, and response is the response that we get back from the network request. So as you can see, we've got that here in a tuple. So the next thing that we're going to do is we're going to see how we can actually throw our own error from here after our function to request our data resumes. So let's do that now. Okay, cool. And as you can see, we're just casting our response, checking the status code is 200, and if it isn't, then we're just simply saying here that we want to throw an error. Now, this is a lot safer than what we had before, where we had our closure, because now we're actually saying here that, like, if this fails at this point, then throw it. So we're not actually able to actually miss any of the possible cases, because a lot of this code is actually procedural one after the other. So the next thing that we need to do is actually decode our data, and if it successfully decodes it, then we're going to return our characters, and if it doesn't, then again we'll throw another error. So let's do that now. So what we've done here is we've got our JSON decoder. We tried to decode it from the result that we get back from our API, so from the data. We mark our decoder with try. So if at any point this decoder fails, this will actually automatically throw an error for us to capture and handle from there. And if everything's okay, then what we'll do is we'll return the results, which is the array of characters that we get back from the service. So now that we've written everything that we need for our character service, if you actually compare this to what we wrote before, you can see there's a massive difference, because number one, it's easier to read, and number two as well, we can make sure that we capture all errors that are thrown as well. So the next thing that we need to do is actually write our view model, which will actually use this service to interact with the Rick and Morty API, and we can actually handle getting the results back and using this within our SwiftUI view. So first of all, what we're going to do is we're going to create a new folder here called view model. And then within this folder, we're going to create a new class this time. So we're not going to use a struct, we're going to use a class called character view model. So this time with our view model, we've actually used a class rather than a struct. So again, why do I use a class and not a struct this time? So with this character view model, this is where we're actually going to So with our character view model, this is actually where we're going to bind our array of characters to our view. So in order to actually do that, we need to make sure that our class is an observable object, so that our SwiftUI view can check for these updates, and if there is an update to a data property, it can re-invalidate itself and render those new changes. So we've got a function here called getCharacters, which is what we're going to use from our service to actually execute and get our characters like it says. So what we need to actually do now is actually inject our service into our view model so we can actually use that function. So we're going to use dependency injection to do this. So let's write that out now. Okay, cool. So now that we've written this out, so now we can actually use our function that we defined before, which is its only purpose was to interact with the service within this class. Cool. So the next thing that we need to do now is we need to actually hold a published property, which is going to trigger some events to our content view to tell us what the current state is of our view model. So let's type this out now. So we've got our enum here, state, and it has 4 possible cases. So NA just means not available. Loading means that the view model is currently loading. We have success, which tells us that everything was successful and here's the data that you want. So we're using an associated value with our enum to pass that data through. And we also have failed, which again is using an associated value to push any errors through. So we can actually handle that as well. So what we're going to do is we're actually going to have our published property here. So this published property that we have is marked as private set. And the reason why I've marked this as private set is because I want the view that you have, the view that has access to this view model, to be able to access this state property, but not be able to actually change it. So the contents of this variable can only be changed within the scope of this class. And then by default, we're actually going to set the state to be NA, not available, because nothing's happened, so it isn't available. So what we need to do now is actually write out some code within our getCharacters function to actually trigger our service. And depending on the result, then we're going to change our state. So the first thing that we need to do is actually mark this function as asynchronous because we want this to also be an asynchronous function. Okay, cool. And then within the getCharacters function, I'm just going to do a bit of typing and then we'll break it down. So let's go and break this down. So we've got our function here, getCharacters, which we obviously marked as asynchronous. We've also got our first change of state here. So we're saying here that when we call this function, the first change should be that it's loading, which, you know, it's just started, so it is loading. So then after this, what we're going to do is we're going to await our call to fetch our characters. And if this doesn't fail, so if this function doesn't throw any errors, then we will get it and put it inside of our characters constant here. So if this is all good, then what we'll do is we'll then change our state again to success and we'll pass our characters via our enum. Now, in the event that fetch characters fails, what we'll also do is we'll actually catch any errors and we'll basically say here that we want the state to be failed and we'll also pass through that error so we can display it on the screen. So as you can see, whenever you use a function that's asynchronous, you need to also make sure that you mark it with the await keyword. Now, it's also worth noting that not every single asynchronous function needs to throw. As you can see here with our getCharacters function, we're just basically saying this getCharacters function is just an asynchronous function, and that is it. So when you're doing your functions, try to think if it needs an error. So if it's possible that it might cause an error and you need to handle the error, then you want to mark it as throws. But if you don't need to handle any errors, then you can just mark it as asynchronous. So the next thing that we need to do is actually talk about actors. So because we're actually making changes to our UI within our view model, we actually need to make sure that these changes that we make are actually on the main thread. Now, right now, we've got a possible problem because we're not actually ensuring that our changes to our state are made on the main thread so that when our view updates, it happens on the main thread. So in order to do that, what we need to do is actually mark our class here using an annotation called main actor. So by using the main actor annotation, what we're saying here is that we want to publish any kind of UI updates back onto the main thread. The next thing that we need to do is we actually need to use this view model within our content view. So let's go into our content view, and at the top here inside of our content view, I'm going to create an instance of our view model and inject our service into it as well. So let's do that now. So now that we've got our state object here, we actually need to call our function to interact with the service. So what I'm going to do is I'm actually going to type out a navigation view. So I'm just going to add a navigation view in here. So how do we actually call the function on our asynchronous function? Now you may be wondering and thinking that actually, you know what, you'd want to do something like this where you do on appear and then you call the view model and then say get characters. But if you actually do this, you'll notice that Xcode actually gives you an error and says that an asynchronous call in a function does not support concurrency. So what does that mean? So what it's saying here is that the onAppear modifier doesn't actually support concurrency in terms of the fact that you can't call an asynchronous function within this block. So what we actually have now in SwiftUI 3 is a new modifier to handle asynchronous functions when we want to execute them when views appear, and it's called task. So rather than using the onAppear, what we want to do is we want to use task. And now what we're saying here is we're using our task modifier to execute our asynchronous function. So this task, it's worth noting that is bound to the lifecycle of this view. So whenever the view appears, this modifier will be executed. So now what we need to do is we need to mark our asynchronous function with the await keyword to fix this error as well. So now we've got this working. So when our navigation view comes onto the screen, what will happen is it'll execute the get characters and the task will be executed. And likewise as well, if this view was to go off the screen and just disappear or get destroyed, the task will actually be cancelled for us automatically as well. So now what we need to do is actually use our view model state within our navigation view to show a list of names in our app. And also as well, when it's loading, we want to show some kind of progress view. So let's do that now. Okay, cool. So let's break this down. So we've got our view model state here. And what we're saying is that if there's a success, what we're going to do is we're going to get the data that we got back from our success. And we're going to loop through it using a for each and use the ID of the character. So remember in the model, we had the ID. So we just go to the model again. We're using this ID as the unique identifier for it within our for each. And then we're simply just going to show the person's name on the screen in a text object. Also as well, we're going to add a navigation title bar to the screen called characters. Likewise, if it's loading, then we're going to show a progress view. Or if none of these cases match, if we don't match any of the other cases, such as the NA or the failed one, we're just going to show an empty view. So what we're going to do now is we're actually going to resume and actually run this and see what happens. That's really quick. But as you can see now, we've actually got a list of all our characters coming back from our API, as you can see. So we want to actually see our progress view because this sometimes the Swift preview is like really quick, you can't really see it. So what I'm going to do is I'm actually just going to run this on the simulator. So let's do that now. And as you can see there, you can see briefly when it's trying to get the data from the API, you can see a progress spin and then it shows our character screen here. So what we need to do now is we actually need to handle errors. So how do we handle when something's gone wrong, i.e. the internet's completely, gone and there's no network connection? Well, in our character view model, we want to actually have another published property within our view model called has error, which will actually handle whether we show a alert dialog with our error message and we can actually retry our network request. So let's do that now. So inside of here, let's create a new property called has error. So we're going to set our has error to false whenever we call the function because there isn't an error. And if there is an error, then we're actually going to set that to true. So let's do that now. What we're saying is that when we start our get characters function, we're going to set the state to loading and that there's no errors. And then depending on whether it's successful, then we won't, has error set to false, so that's fine. But if there is an error, then we're going to set that to true. So what we need to do now is we actually need to use this has error property within our view to show some kind of alert that something's gone wrong. So let's do that now. But what we need to do, before I explain this, we actually need to make a change. So if I actually go into my view model, we need to remove the private set. And then let's build this now and see what happens. Okay, cool. So now we're using the alert modifier. So what we're doing here is we're using the alert modifier and we're using the isPresented property here. So isPresented is checking for true or false and that's checking it through our Boolean here. And presenting is passing through our ViewModel state. So we're using the case that we get failed to actually grab the error message that we want, which we'll get to in a second. So inside of our alert, we've got a button here called retry, and within retry, we create a task. So the reason why we have to create a task is because, remember, like I said before, if you actually want to run a asynchronous function, it needs to be executed within a concurrent context. So that concurrent context is this task. So if you want to execute a concurrent function, you have to make sure that it's executed within some kind of task, and we mark it with a wait to get characters. And then within our alerts message, we get our detail. So we get our state here, so detail, and then we check to see the detail of that. So if it matches our failed case, then we're just going to show the error message within the text for our alert. So what we're going to do now is we're actually going to simulate this. So in order to simulate this, what you're going to do is actually, well, the quickest way to do it is to turn off your internet. And then I'm going to run this on the simulator. Cool. So now we've run that, and you might realize that actually, wait a second, my Wi-Fi is turned off, but I'm still actually able to see a list of characters. So what's going on here? Well, what's actually going on here is that the URL session that we're using, we use a shared instance with a shared configuration. So by default, that URL session actually has caching enabled. So in order to actually see the work that we've done with the error, what we need to do is we need to go into our service class and actually disable caching by passing in our own configuration. So let's go into our character service, and then I'm going to do a bit of typing and I'll break it down. So what we're saying here is we want to use this configuration called ephemeral, and then what we're saying here is that this will actually not persist any kind of data on disk. So all this data that we request using the URL session will actually not be saved on the disk. So we'll only use any data that's available in memory. And then we pass this configuration into our URL session. So what we're going to do now is we're actually going to run this again. And this time we're going to see what happens. So let's run it. And as you can see, because we've now turned off the caching capabilities with URL session, we now get to see our actual error dialog, and it tells us what our error is. So now what we're going to do is we're actually going to turn our Wi-Fi back on. And now that we're connected to the internet again, we're going to hit retry. And as you can see, we now get our list of characters visible on the screen. Now, a word of warning, what I've done here was just literally to test it out so I could actually show you how the error handling works. But normally, when you're working with URL session, you do want to use a shared instance, and you do want to use the caching, because so when you're hitting a network a lot of times, if there's a cache available which has some data that's still relevant, then it makes sense to use that rather than making another request to a service for performance. So looking at our list here, we've pretty much done it, and we've got all our responses back from the API. So we've actually covered everything that we need to cover in today's video. So that's everything from me. If you have any feedback, I'd love to hear it in the comment section down below. Also, as well, if you haven't already, I'd really appreciate if you gave this video a thumbs up. I'd really appreciate that. And as well, if you haven't already, then hit the subscription button. So subscribe to the channel and hit the notification bell so you can get updates whenever I release a brand new video. That's everything from me. I'll catch you on a bit. Deuces.